Calculate the rate at which all the compounds are reacting and the rate at which water is forming if the average rate of formation at a given time of CO2 is 0.002 molarity per second. We have this equation, C5H12 plus O2 reacts to form CO2 plus H2O. I have balanced this equation before, but the first step that you should do is always see and check if the equation that is given to you in the problem is balanced. So what is the rate law? We have this equation as the rate law. Notice that it's negative on the reactant side and positive in the product side. You should always keep this in mind when plugging in your compounds into the equation. So once you plug in your compounds, we put negative on both, and we see that a concentration is given to us because we have it in molarity over seconds. Those are the units for concentration. And it is given us for CO2. So what we do now is we plug in the concentration into this. So 0.002 is equal to the change of CO2 over the change in time. So what I said is all this is equal to this. The 1/5 is accounted for the coefficient in front of the compounds. For example, -1/8 is there because it's 802, and it's negative because it is in the reactant side. 1/6, we have it as 6 because there's a 6 in front of the H2O, and it is positive because it is in the product side. So what we do is that we plug in 0.002 in all this, the change in the concentration over the change in time, and we divide it by 5 to get the change in concentration over the change in time by itself. So this gives us 0.002 divided by 5. It gives us 0.0004, and our units, molarity per second, because it is concentration. So now we have the concentration of this. And it is asking for the rate at which water is forming. So water would be this compound. So since there is an equality in this equation, we can simply say that 0.0004, the concentration of CO2, is equal to 1/6 the concentration of H2O, the change in concentration over the period of time. So now we have to get this concentration. How do we do that? We multiply times 6 on the other side to leave this by itself, and this gives us a concentration of 0.0024 molarity per second. And that would be our answer to find the rate at which water is forming. Similarly, we can do this for O2 and C5H12. Since we know that there is a equality in all of these compounds, we can do the same thing for O2 and the same thing for C5H12. I'm going to do it real quick. 0.0024, we keep our units, is equal to -1/8. And what are we trying to find? The change in concentration over the period of time. We multiply this times -8, and it is decreasing at a rate of 0.0192402. Similarly, we can do this for the change in concentration of C5H12. So we have the change in concentration for C5H12 over the change in time is equal to 0.0004. We can use any value that is given to us because it's an equality. So I can use the change in concentration of this or the change in concentration of this. It will all equal the same. I'm going to use it for this value, which is 0.004, and the change in concentration of C5H12 is the same, but it is decreasing because of the negative that was in front of the C5H12. And that is our problem.